Let's do the New York Times Easy Sudoku for April 13th, 2024. I'm not going to do this one every day, but I thought I would do a in-depth tutorial series if you're very new to Sudoku. You want to learn how to do Sudoku. I'm going to use this New York Times Easy puzzle as an example because it's one maybe you would have tried. And so if you want to learn how to solve Sudoku puzzles, why not start here? And then you will very quickly graduate to the New York Times Hard if you follow my strategies. And so you might as well start watching my New York Times Hards ones as well. But I'm hoping that maybe this comes up in a search of like, how do I even play Sudoku? So if that's you, this video is for you. I'm going to explain not only how to play Sudoku, how to complete the puzzle, but how to do so in an enjoyable way that's sustainable, that's not going to be boring. So Sudoku can be a lifetime hobby if you let it be. If you do it in a way that you let it take you on that puzzling journey. So sorry for the long intro, but why don't I start by explaining what is Sudoku and how do you play it? What are the rules? And then we'll start the solve, and I'll go over strategies as we do the solve. So Sudoku, all about the numbers 1 to 9. People think it involves math because it involves the numbers 1 to 9, but it could also easily be letters. You know, it could be A to I. It could be pictures, 9 different pictures, right? It's just 9 different objects. And I'll explain why. So our goal in Sudoku is to fill every cell with a number. Doesn't sound hard, right? Just pick a number, right? Well, there's more to it. We are not allowed to repeat any digit. I'm going to call them digits from now on. We're not allowed to repeat any digit in any row, right? So there's a 7 in this row, right? So if I try to put another 7 in the row, what this software is telling me is, hey, it's red. You can't do that. You can't repeat the 7 in the row. It's also complaining about the column. So that's a little bit of a head start if you want to think about that. But we're not allowed to repeat any digit in any of the rows. So every row will end up with 1 through 9 exactly once each. Notice there has not been any math, and there won't be. There are Sudoku variants that involve math, but classic Sudoku, like what you're going to find in the New York Times, no math. So don't worry about that. There is logic, and it's fun logic, but there's no math. All right, unless you consider logic to be math. All right, so none of these rows, and if we want to number the rows, we can call this row 1, row 2, row 3, etc., all the way down to row 9. So there are 9 rows, and for each of the rows, we are placing the digits 1 to 9 once each, without repetition. All right, same deal with columns. There are 9 columns. We can label them left to right, column 1, column 2, column 3, column 4, etc., all the way to column 9. In each column, we're going to have 1 through 9, exactly once each. This is going to sound very familiar. So if I wanted to try to put a 7 here, I wouldn't be allowed to. Let's pick a different spot. All right, 7 here. I wouldn't be allowed to because I'm not allowed to have 2 7s in this column. I need 1 7, and I need 1 of each digit. And because there are only 9 cells in the column, just like there were only 9 cells in this row, each cell is going to get filled with a different distinct digit from 1 to 9. Finally, you may notice that we have these sort of 3 by 3 boxes that are denoted by these bold lines. There are 9 boxes. You might see where this is going. In every box, we are placing the digits 1 to 9 exactly once each without repetition. So if I wanted to try to put, let's say I wanted to try to put a 3 here, there isn't another 3 in the row, and there isn't another 3 in the column, but there is another 3 in this 3 by 3 box. So we are not allowed to repeat the 3. Each 3 by 3 box is going to end up with exactly 1 of each digit without repetition. If we want to number the boxes, we start here. This would be box 1, box 2, box 3. Then we go back around, box 4, box 5, box 6, all the way to box 9. All right, so those are all of the rules to Sudoku. There's also kind of a hidden rule, which is going to be true of any published Sudoku you do. That's worth its salt, because Sudokus need to be logically solvable. It is not a guessing game. If you play it as a guessing game, you're going to get bored quickly, and you're going to get frustrated. It is a logic game. When we place digits in Sudoku, we only place them because there's no other choice. We have proven that that cell must be that digit in order for the Sudoku to be valid at all, to have any solutions at all. But the unwritten rule is that there is only one possible solution. So with the givens that we're given here, these are called givens, the numbers that are already there in black. Those are called the givens. That sets up our puzzle. With that set of givens, there is only exactly one way to fill each cell with a digit. So if this ends up a 2, it was always going to end up a 2 in this puzzle. It could not have been any other number. So if we fill in a number, we'd better be confident that it's going to be that number, because there is no way we're going through every permutation of what all of these cells can be and like brute forcing that. That is not the point of Sudoku. So that leads us into starting to solve the puzzle. I'm going to reset my timer here. So what are some strategies we can use to solve the puzzle? Well, one strategy is what's called hidden singles. The way a hidden single works is we identify that in a row, column, or box, remember every row, column, box, we call these boxes, right? Every row, column, and box must have one of each digit. So, for example, think about this box. Where does the 1 go in this box? Well, it's not any of these that are already filled with not ones, first of all. So we've narrowed it down to these 3 cells. But this column already has a 1 in it. So what we're going to do to scan for this is we're going to look for givens that look into other boxes. When I use the word look, I'm talking about how a digit will look at its row, it'll look at its column, and it'll look at its box. And these cells here, I'll highlight that in green. None of the green cells can be a 1 because there is a 1 in this purple cell. So this purple cell eliminates 1. It looks at all of the green cells and says, you can't be 1 because I'm 1. So when I say look, that's what I mean. So this 1 looks into this box, and you can notice the only open cell that's not green is this one. We need a 1 in this box, and this is the only cell that can have a 1. That's called a hidden single. So we can place a 1 there with confidence. All right. The next thing I'm going to do is I'm going to look at what are the 2 digits that haven't been placed in this box yet. And the answer is we have the 1, we don't have the 2, we have the 3, 4, 5, 6, 7, 8, and we don't have the 9. So we want to think about 2 and 9 in this box. Well, the 2, it looks like can go anywhere, because there better not be a 2 in this column, otherwise we won't be able to place it in this box at all, right? There was a 2, for example, here. This puzzle would not work because I would have nowhere in this box to put a 2. So luckily that's not a 2. But the 2 looks like it can go either one. But what about the 9? Well, this row has a 9 in it already. So this cannot be a 9. We look right through the row and we go, oh, there's already a 9 here, and we need a 9 in this box. So that is actually a hidden single, another hidden single. This 9 looks in this box, places a 9 here. And now there's only 1 digit left that can be placed in this box, which is a 2, and there's 1 cell, open cell. Whenever there's 1 open cell in a row, column, or box, you can just immediately place it. So this is a 2. And now notice what that did is in this row, we have limited this row to only a single digit. And so we can place a 3 there. Because we had the 1, 2, 4, 5, 6, 7, 8, and 9. 3 is the missing one, so we place the 3. All right, well, let's think about this box, right? We just placed a digit into it. Let's think about this box. We are down to the 1 and the 1 and the 2. The 2, again, could go anywhere. It can go in either of them. But what about the 1? Well, this cell sees a 1 down here. So this can't be the 1. So we have another hidden single. This is a hidden single 1. And this is a 2 now. Let's look at this row. There are only 2 digits left in this row. What are the digits this row needs? It needs a 1. We have 2, 3, 4, and it needs a 5. It has 6, 7, 8, 9. So we need a 1 and a 5. Well, the 5 can go in either of these, but again, we have this 1 making this not a 1. This 1 looks at this cell and says, you can't be a 1. So we have a hidden single 1 in the row. It's also in the box, but we also have it in the row. So either way, this cell must be a 1, or the row and the box don't get 1. It needs 1. So now for this row, we need a 5, or the row is basically done, right? There's only 1 open cell in the row, so we can just place what the missing digit is, which is 5. Now there are 3 digits left in this box. Let's think about it. We need a 2, a 3, and a 7. What I'm noticing is that we have 2 3s down here. So here's my introduction to scanning. We're going to introduce it very slowly. But when I say scanning, there's a lot. It means we're looking for things in the grid, and we're training our brain to find certain patterns in the grid. And we're using the information in the grid that we have that's marked up. So we have these threes here, for example. So if we were to look, this is called, by the way, 3 boxes on top of each other, basically a column of boxes is called a stack, and a row of boxes is called a band. Slowly introducing terminology here. But if we want to scan this stack, what we can do is we can look for duplicate digits. So for example, we have 2 3s in the stack. We need one more 3. It's not going to repeat in this box, and it's not going to repeat excuse me, in this box. So our third 3, we know there's going to be 3 3s because there's 3 boxes, there's 3 columns, there will be 3 3s. 2 of them are accounted for. So there's only one box that can have the other 3, which is here. What we can do is we can look at these 2 3s and how they affect this box. They look at these cells and they look at these cells, saying these can't be 3. And we also notice that in this box, these 2 cells are filled with non-3s. The box still needs a 3. So this is a hidden single 3 in the box, and we found it through scanning. We also, you may notice, you may have been looking ahead and seeing that we have 2 1s also in this stack. They affect the box they aren't in. They affect this box. And this 6 and this 9, though very nice, are not 1s. So the 1 in this box can only go here. So we can place that, another hidden single 1. All right, we can continue to scan this stack since we seem to be fruitful here. We have 2 6s, but we also have a third one, so we don't care about that. So what we're going to do is we're going to focus on one of the boxes, and we're going to look at the other 2 boxes and see where the buddies are. So I'm just gonna start at the top. Here's 6. We have 6s are already done. How about the 9? 9s aren't done. We have a 9 here and we have a 9 here, but this box, it does not have a 9 yet. So this 9 looks in, this 9 looks in. The 1 and the 8 are not 9s, so we can place the 9 in the box. All right, let's continue scanning this box. We have the 3. We have all 3 3s. We have the 1. We have all of our 1s and the 2. Okay, so the 2, in this case, there is no buddy. But what I am noticing is that we have a 2 over here as well. So this is a little bit more advanced scanning here. But we have this 2 looking into the box like this. And we have this 2 looking into the box like this. So I basically asked myself, okay, first of all, does this box have a 2? No, it doesn't. So it needs one. Where can the 2 go? And I'm seeing this, and I was focusing on this 2 down here, and I was seeing how it affects this box. So it only took a glance left to go, is there another 2 that might be helpful? And I found it. It's right here. This 2 looks in like this. And 1, 3, and 8 are not 2. We need a 2 in the box. There's only 1 cell for it. That's a hidden single 2. Very nice. All right, so that's our 2. So we finished this box, and we compared it against these 2. Now all we have to do is compare these 2 boxes against each other to see how they affect the bottom box. So let's just start here. 8s. Well, we have 2 8s looking down. This box needs an 8. Now here is an introduction, our first introduction to notation. In this puzzle, you probably don't need to, but it can help speed you up. You notice right now, I have not used any notation. I could probably finish this whole puzzle without notation, but I want to introduce you to the concept. We have discovered that this box needs an 8, and it is limited to 2 cells in this box. That sounds like something important to remember. We could try to remember it. That's one strategy, but we can also notate. Now this Sudoku Pad software I'm using supports 2 kinds of notations, corner marks and center marks. And just by convention, I use corner marks, which look like this. I'm going to corner mark 8s here. And whenever I have corner marks, I mean them, and I only ever mean them to mean that within a box, I have limited that digit to only those cells in the box. And I generally limit myself to only corner marking when there are 2 places left in a box. Sometimes I will do 3 places, but only if they're all in the same column or all in the same row. So we note those 8s. That means we don't have to quite remember it. So we can come back later and utilize that. So we found the 8s. Let's keep looking. So 5, there is no 5 buddy in here. We do know that this box needs a 5. In fact, this box is down to 2 digits. Let's think about what they are. They are the 4 and the 5 is what's missing. Well, I just noticed that this 4 is taking the 4 out of here. So we have a hidden single 4 and then a hidden, and we also had this 5 making this not 5. So we had a hidden single 4 and a hidden single 5, or if you prefer, one of them was a hidden single, and the other one finishes the box. This column has only 1 cell left, so we can just finish it with what the missing digit is. We have 1, 2, 3, 4, 5, 6. We are missing the 7. We can place the 7 there. This box now only has 1 digit left, and we can place the 2. All right. So now what we have here is we have 2 columns left here that with 2 cells each. If we're in that situation, it might be good just to think about what are those 2 digits. So this column, what 2 digits is it missing? It has the 1, 2, 3, 4. It's missing the 5, and we also know it's missing the 8 because we have that cornered here. Now, of these 2 cells, this 5 says this one's not a 5. So that places a 5 here. We also could have seen that by seeing these 2 matching 5s looking into here, and then this 5 looking down, keeping that from being 5. So we have a hidden 5 in this box here. Now, look what's happened here. As soon as I place this 5, I am noting that one of my 8 corner marks is now gone. I don't have an 8 corner mark anymore. I still need an 8 in the box. So this 8 corner mark is noting the final cell that can be 8 in the box. We have a hidden single 8 in the box, and the corner mark has told us that without us having to rescan. So I can immediately place that 8. And now we want to think about the 2 remaining cells in the column or the box, whichever one's easier for you to scan. We know that one of them's a 4. I'm seeing this 4 look in, so we have a hidden 4. And then we finish the box with a 7. Nice. So we have a lot of our boxes finished now. So where do we want to look next? Well, I kind of started with this band. I noticed this stack was pretty nice, so I skipped ahead to this stack. But if you want to be systematic, after doing this band, just move on to the next band. Scan this band next. So we're going to scan it in the way we were scanning this stack. So we're going to look for duplicates. So let's start with this box here. We've got 1, 2, 3, and 8. So the 1 looks into this box, and it has this buddy 1 looking in. We also have this one looking in. We want to look at all of the ones that can affect this box. Because we started with this one, we just look at all of them. And we note that there is a hidden single 1 in this box. Now we want to look at the 2s, because I'm just moving along through in some order. I think I'm going in numerical order this time. Doesn't matter, whatever order makes sense to you. We have all these 2s looking in. This 2 looks down. However, there isn't a 2. 2 can still be in one of these 2 cells. So what do? We either try to remember it if you want, or you can just corner mark 2s there. And that'll remind us. All right, move on to the 3. You can already probably see the 3 ends up here, right? We have this 3 and this 3. They look in. These aren't 3. The box needs a 3. Only place for it's here. That's a hidden single 3. We have this 8, but we have all the 8s, so that's not helpful. Now I'm going to focus on this box, and I'm going to see how it affects this box here. So let's go in numerical order again. 1s are done. 3s are done. 5, this box needs a 5. So we have these 2 5s. They look in. And I'm looking for other 5s. We have 2 more. If you ever have 4 of a digit looking into a box, you can always place it. Unless you've broken the puzzle. So you can place the 5 there. All right. We are on the 5. How about the 8? 8s are done. 9s. Okay. We have these 2 9s looking in. These are not 9. So we can place the 9 in the box. All right. So to sort of continue looking at this band, the next thing I would do, we have like this row here. We have this row here. All of the rows, really, they're down to 2 or 3 open cells. Always good to at least think about what they are and then determine what you want to do about that. So we have 1, 2, 3, 4, 5, 8, 9. So 6 and 7 are missing. You will notice we have a bunch of 6s and 7s here. So that tells us the order, right? This can't be the 6. So this ends up being the 7, and this is the 6. Now the box is finished. We just need to know what digit's missing, and it's the 4. This row is finished, just one missing digit. That's the 7. And now we just have 3 digits left for this whole stack, or sorry, this whole band. I used the wrong word. Sorry about that. 2, 4, and 6 are what's left. So we want to think about 2, 4, and 6. Well, first of all, this column's done. It only has 1 open cell. It has a 2 and a 4 in it, though, so we know it's going to be the 6. And then we have 2 and 4 left. This 4 tells us this is 2, and then this is 4. All right. We just have 1 more band left. It might be more fruitful to do the stacks, though. So we can skip ahead to the stacks because we have completely full boxes. So every digit's going to have a buddy. So whatever digit is missing from here is going to already be just very, very limited. So let's just go 1 digit at a time. When we're down to this few, I like to display what does this box need. So this box needs a 1, and we can see these 2 1s looking down, and we can see these 2 1s looking in. So we can place the 1. The box needs a 2, so we have this 2 looking in. We should have another 2 as well. And then this 2 happens to look in as well, so we can place the 2. 3s. 2 3s look down, this 3 looks in. place the 3. 4s, 2 4s look down. This 4 looks in, we can place the 4. We have a 5 already, we need a 6. Find the 2 6s up here, place that 6. We have a 7, we need 8 and 9. This 9 tells us this is 8, this is 9. And now we can play what this box need. When you only have one box left, every other box is filled, it's always going to just be just one place left. So we need a 2, and it's just about finding where the 2 can go. So we have this 2 looking in, we have this 2 looking down, and we have this 2 looking in. So the 2 goes there. We need a 3, which goes there. We need we have the 4 and 5. We need a 6. These 6s look in, so we can place this 6. This 7 looks in, so we can place the 7, and then the 8 is already there, and we place a 9, and we are done with the correct solution. So, as you can see, the hidden single technique is extremely powerful, especially in the New York Times Easy puzzles. So why not practice that? Practice your scanning. Look for those hidden singles. I didn't even go over the naked single. You may need that sometimes, but let's go over, you can kind of think about when we had only one digit left in a row, you can kind of think about that as a naked single if you want. What a naked single is, let's see if I can find one in the grid from the start. So let's restart here. Let me see if I can find one. I probably can. Yes, this cell here. So you're welcome to use naked singles. With the scanning technique I introduced, it's actually easier to find hidden singles. So the names are kind of backwards, and they're backwards for a reason, because the technique I'm using is kind of a more modern technique before a lot of or after all these techniques are already named. So with the hidden single and naked single, you can solve any New York Times Easy puzzle. Here's the naked single. This cell needs to have a value in it. Every cell ends up with a value, as you know, because we just finished the puzzle. So you can just think about, what can this cell be? Well, it can't be a 1. It can't be a 3, 4, 5, 6, 7, 8, or 9. The number I skipped was 2. Luckily, I skipped one of them, because if this was a 2, for example, this cell could literally not be anything. It couldn't be a 1, it couldn't be a 2, 3, 4, 5, 6, 7, 8, or 9. It couldn't be any value. We have broken the puzzle. That's why this cell can't be a 2. One of the many reasons it can't be a 2. Remember, there's only one solution to the puzzle. One solution means that it's already been predetermined what this cell's value is going to be, and you're not going to be able to make it anything else and still solve the puzzle. We just don't know what it is yet. Well, we do. We solved the puzzle, but I don't remember. But we know it's not a 2, right? This cell has to be a 2. If I try to fill a 1, I break Sudoku rules. If I try to fill 3, I break Sudoku rules. 4, 5, 6, 7, 8, 9. If I don't want to break Sudoku rules and I still want to fill a value, I have to fill a value. I have to fill a 2. That's called a naked single. It's called a naked single because it's nakedly a 2. It has no other choice. Just looking at the cell and what values are already in its row, column, and box that are looking at it. So that is a naked single. You are welcome to look for naked singles. I think that they're harder to find than hidden singles if you use the scanning technique that I introduced in this puzzle. So anyway, I hope this was helpful. Let me know if you have any questions in the comments. And if you want to learn about more advanced techniques beyond singles, you do need those in the New York Times Medium and New York Times Hard. So you're welcome to look at my solves of those. Start introducing yourself. Just immerse yourself in, even if you don't try it yourself the first few times, if you just watch me solve it, I go over exactly how these techniques work, give you a little preview of things that you might need in the future to solve any of these New York Times Sudoku puzzles. And pretty soon, if you keep at it, you will be in my comments saying, I solved the New York Times Hard in under 20 minutes, and I'm very proud of myself, and I'm also proud of you. So let me know if you do go on that journey. I hope this video was helpful. I'm hoping this will be an evergreen video for people searching how to solve Sudoku, a nice introduction to it. So let me know if this was helpful to you. And if it was, why not leave a like, subscribe, and a kind comment below.